This plant will process over 10,000 cubic metres of intermediate level radioactive waste and have an operating life of approximately 20 years. It's therefore important that we have a rigorous underpinning of both the design and operability of the plant, as it represents a major investment. We do this through two routes. One, through our design processes, which employ a range of 3D modelling tools. And with using these tools, we explain the design to both the safety case team, the modellers that complete the throughput analysis, the commissioning engineers and the operators of the plant, so that we obtain their input and buy-in to the final design solutions. The second way we do this is by designing and manufacturing a range of test rigs. The process is fairly unique and the feedstock is unique. And so the operability of those test rigs, from small scale through to large scale rigs, provides the necessary information needed to underpin the design and the process. We have a number of very important stakeholders. The first is our customer, his engineering team and the operators. Those people are involved in the design development, and through a series of presentations and formal submissions, regularly they obtain buy-in to the design development of the plant. Secondly, there is the nuclear regulator, and the interface with them is through the safety case for this plant which we are producing. The final product of the plant is accepted by a further regulatory body, and we have to provide information in the form of reports and submissions to them. And lastly, there's the ultimate sanctioning body for this project. We have to demonstrate that our design solutions are economic and effective from an engineering viewpoint.
Integration is vitally important for you to successfully deliver a large project or a large process plant. Nuvia have a number of well-experienced discipline delivery team organisations within our structure that are used to delivering multidiscipline delivery systems. A key point in that relationship is the interaction with the engineering and the safety case and the nuclear conventional safety issues associated with the plant design. We physically embed safety case authors and those conventional safety experts within our delivery team, so that the safety case issues that can be engineered are engineered out at source, and if they can't be engineered out, that dialogue happens directly with the authors. And a method we use to develop resolution of those are associated with space management. Space management of a multi-floored process building is vital again. We try and develop that early within the design. Major process routes, operation K-face views, and any maintenance issues associated with that, we drive forward by having regular, well-communicated forums to get those issues raised. We encourage people to raise those technical issues up early so we can get early resolution during the design. So fundamentally, just to summarise this, we have the SQUEP personnel experience in delivering a project of this size. We have the procedures and mechanisms in place to then hang those experiences upon, and we have that fundamental important one, which is a track record of delivering large projects of this size. Component design needs to be considered from the overall process and how that component design fits into the overall jigsaw of the actual delivery. Component design can be developed in a number of ways. We tend to use a lot of 3D finite element analysis to develop a lot of bespoke design elements. There's a lot of cost benefits associated with doing that from an FEA analysis point of view. It tends to focus the designers into key critical parts on the design. These parts can be validated at a later date too, so you can focus on critical areas within that development. It allows you also to visualise. The designers can actually see in 3D space how the component behaves in its environment. It gives a lot of client confidence in the end product. Performance assessment is vital to a successful delivery of a major plant. The functionality targets that you're aiming at from a plant design development point of view are vital. To do this, we tend to model it in a number of ways. One element of the modelling work that we do is associated with its throughput, how reliable the plant is, how available those components within that process achieve what their targets are, how maintainable the plant is as well. So we have a number of modelling software packages that allow us to get early definition of that, so that designers can then focus on these critical bottlenecks within their process flow. So it's vitally important that we focus on those and try and resolve them. Another key item associated with performance is the functionality. An early stage of the design tends to change with time. So we're considering that functionality all the way through those process steps. During the design, how the plant performs during installation, how there are optimised ways that we can actually deliver those installation routes. Also during construction itself, are we going to pour walls in a slightly different configuration? Can we hand over parts of the plant in a different sort of phased approach? That tends to reduce our overall delivery duration as well, makes the client very happy, but we also need to focus on the final operation performance of the plant too.
As the process is unique and the feedstock presents some significant challenges, we are using a range of test rigs from small scale through to large scale, right up to full prototypical stage rigs. The rigs provide us with the capability of optimizing the plant's performance well before manufacture and construction takes place on site, thereby considerably reducing the project risk. The expenditure on the rigs represents a fraction of the overall capital cost of this plant, together with the through-life costings. We have deployed a strong multidiscipline engineering, design and project management team on this project, allowing us to integrate all aspects from design concept through to delivery of the rigs and prototypical plant. Our design software has allowed us to visualize the plant design, showing the solutions and challenges and sharing these with the operators, commissioning engineers and safety case team. The rigs and trials provide an off-site capability as a stage short of final construction and commissioning of the plant when faced with active materials. Our design solutions, analysis, modelling, trials results provide the necessary underpinning to give a high degree of confidence to the customer and to the regulators.